It is late in the Math 3 Unit 2A review game. If you are a student of mine, please feel free to leave a friendly comment, and all viewers are encouraged to like and subscribe. Yes, I said it. Number 1, determine the degree of the polynomial 3x to the 5th minus 4x cubed plus 7x plus 14. I just want you to simply ask yourself, which exponent has the greatest value? That will determine the degree of the polynomial. And yes, our x has the one we don't see, but we have an x to the 3rd and an x to the 5th, with 5 being our greatest valued exponent. I am just going to write a 5 and circle it. Go on to number 2 to simplify. Negative 3x to the 5th plus 10x cubed plus 6x squared plus 18. We do see a subtraction sign. 8x to the 5th minus 12x squared plus 15. All right, I am going to highlight the subtraction sign. That's going to determine something for us. That is going to tell us to flip the signs of the polynomial to the right. So we're going to flip the signs here, because technically we would be distributing a -1 to all three terms, and -1 times positive 8x to the 5th simply becomes a negative 8x to the 5th, and -1 times negative 12x squared simply becomes a plus or a positive 12x squared, and a -1 times a 15, yes, becomes a negative 15. All right, well, nothing changes in our first polynomial. Right above it, I'm just going to write stays same. All right, because if I'm a student taking notes, I might want to write that there just so I have that as a reference to reflect back on. From here, we simply combine like terms. That's it. I am going to circle my minus 3x to the 5th or negative 3x to the 5th. And is there anything else with an x to the 5th? Certainly is. I know I heard it shouted out. -3 minus 8, -11. Don't forget your x to the 5th. All right, I am going to box our 10x cubed or 10x to the 3rd. We have a 6x squared, 18. I don't see anything else x to the 3rd, but we do need to include it in our answer. I am going to underline 6x squared, and I am going to go down the number line. Do I see anything x squared? We sure do. 6 plus 12 gives us an 18. Don't forget your x squared. I'll double underline our 18, and I'll double underline our -15. And 18 minus 15, wonderful, gives us a +3. Go ahead and circle your answer. Now, if you're looking for it, please, minus 6x squared, wrong there. However, take a look at answer choice B. All right, now after you figure out that first term, all right, when you combine -3x to the 5th minus 8x to the 5th, and you get that -11x to the 5th, well, test-taking strategy, eliminate at least 2 of your answers. All right, and then see, well, heck, can we eliminate 3? I don't know. But look for number 3 here. Oh my goodness, Mr. Richards, what did you do? Well, I pre-built this in here. Okay, I probably shouldn't have. Only reason being is I would rather distribute 2 terms to 3 as opposed to 3 to 2. All right, especially for the coloring sake as we go through this. -4x squared times 8x cubed. I think I heard it shouted out. Yes, -32. But what is it? X to the wonderful x to the 5th, because remember, we multiply the coefficients and we add the exponents. We will do -4x squared times -7x squared, giving us a positive 28x to the 4th. Wonderful job. -4x squared times -5. Wonderful. Plus 20x squared. Then we just have to take our second term here of this +6 and do the exact same thing. Times 8x cubed plus 48x cubed, or to the 3rd power. 6 times -7x squared. Wonderful. The negative Jackie Robinson. Don't forget your x squared. And 6 times -5, negative Steph Curry. Let's call it a 30. All right, so we will simply from here, again, just combine like terms. I'm going to circle my -32x to the 5th. I do not see anything else that's x to the 5th, so let's just simply rewrite it. I will box my 28x to the 4th. Is there anything x to the 4th? I don't see anything, so I'm just going to go ahead and write it. Now, If I'm going to do this in standard form as I go through it, well, x to the fifth, x to the fourth, let's check to see if there is an x to the third. Wonderful, there is. But can it be combined with anything? No, it cannot. So I'm just going to simply write it again. All right, I'm going to double underline my 20x squared. Anything else x squared out of the other two terms? Sure is. 20 minus 42, the negative double deuce. Don't forget the x squared. And we'll star our negative 30 and circle our answer. Make sure to include it and then circle. Wonderful. Moving forward to, what are we on, number 4? Ooh, write the factored form expression for x to the 6 minus 225. We will be working with a difference of squares using a plus b, a minus b for our quantities. And what we need to do is we need to find our a value and our b value. All right. So our a value is going to stem from that x to the 6th, okay? If we take the square root of x to the 6th, okay, that's going to be equal to, well, let's just see, x to the 3rd squared. So our a value is simply just going to be x cubed, which equals 8. Do you have to write all that out? No, you simply could have just wrote x cubed. All right, no big deal. Now, if you're x to the 4th, well, then the square root of x to the 4th would be x squared. And if you're x squared, your square root of x squared is simply just x. All right, so our a, I'm just going to plug in where I see it. And if we know it's x cubed, well, I'm just going to put x cubed, or x to the 3rd power. And I'm simply just going to write it again. Next thing we need to do is find the square root of 225. Well, the square root of 225 is, yes, I think I heard it again, 15. So our b equals 15. And then we're just going to simply plug that in. So it's truly that simple. Guys, that's all it is. If you were uncertain, you can pull in your calculator. You can hit second. All right, you can hit x squared. Do not make an arithmetic error when we do not need to. Hit 225. Yes, we get that b equals 15. Move on to the next one. All right, number 5, identify term 4 in row 6 of Pascal's triangle. All right, so again, we're just going to look for row 6. I did highlight that in green. I think I may have done it a little prematurely, so sorry about that, but I'm just going to go to row 6, and I'm going to work all the way down. Now, when we're looking at the triangle in specific, all right, our first coefficient here, our first term, is always going to be 0 in every row. So if we're looking for term 4, well, we have term 0, term 1, term 2, term 3, and then term 4 right there, that 15. I'm going to go ahead and circle that in green just so you guys can see that. And I would definitely take this note right here if I'm a student. Do we have to put the smiley face? Certainly not. All right, circle your answer, move forward to number 6. All right, it's asking us to expand the binomial negative 4x plus 2y to the 5th. We need to find our a equals and our b equals. All right, that's going to be the first thing we do. Now, our a value is the coefficient of x, the number in front of x, which is, didn't mean for that to happen, negative 4. Did I want to highlight the parenthesis with it? No, just kind of happened. All right, and then we will highlight the coefficient of y being, yes, positive 2. That will be your b value. Now, one more key component here. This is the way my mind perceives it. All right, so if you learned it a different way, I'm sorry. I don't mean to throw you off if I do, but if it does assist you, please feel free to let me know in the comments. All right, so that to the 5th power right there, what I'm going to do with mine is I'm going to go down to row 5 of the triangle. And I'm going to know that I am going to use that entire row of coefficients. All right, so the 1, the 5, the 10, the 10, the 5, and the 1 now become our coefficients when we expand. So I'm going to write those. I'm going to try to save some space. I might write a little small. 1, 5, what is it? 10, 10, 5, 1. Okay, 1, 5, 10, 10. Hopefully I still have more space. I know, it looks a little bad right now, but trust me, it'll look better in just a little. All right, now, when we're going through this, I'm going to space that a little more. Sorry, guys. All right, if I have the space, I need to use it because I'm not the best at putting these parentheses together. I'm actually going to bring them down a little bit too. I don't want that to get in the way. Sorry about the time it's taking here to get set up for you. But this is the most crucial part because once you're comfortable with it, it truly is so simple. Like, should be zero issues simple. I'm that confident in you guys. I know that you guys can crush and dominate this. It's just up to you. That's all. Oh, goodness. I'm like running out of real estate. I do not like that. But I also don't want it too close to the top. All right, hopefully this works for us, okay? Now, what we remember about Pascal's triangles, yes, it is an exact mirror. This whole thing splits. So we see our 1, drag it right down the middle. It's a perfect split. And look what we have on the perfect split here, the 10 to the 5 to 1, the 10 to the 5 to 1. Now, our first one, all right, is going to get the coefficient of x or a value. I'm going to wrap that in parentheses. All right, now, because it's to the 5th power, it's actually going to be raised to the 5th. So I'm going to drop my -4 in there. And I'm actually going to put the 5 in red because the 5 will symbol our x's or our a's. All right, now the first one gets just the 1x. Now the last one gets just the 1y. And that also goes raised to the 5th. And that explanation will come in just a brief moment because every other coefficient in between, and I'm just going to set these up prematurely just a little bit so I can have them ready for you guys. So I'm going to copy this. I'm going to drag it over. I'm going to hit paste. And I'm going to drag it over. And I'm going to hit paste. And I'm going to drag it over and hit paste. I know, it's time consuming. All right, but you could set this up for yourself like no problem. Now, for the rest, all right, of what we're going to be raised to for our exponents here, well, for our a values, in red, I'm just going to go 5, and I'm going to count down to 1. So I'm going to go 4, 3, 2, 1. Let's write them. We already have the 5 written. 4, 3, 2, 1. All right, now I'm going to do the exact same thing for our blues here. We're going to write those backwards as in 5, 4, 3, 2, 1. All right, we already have the 5 written. So let's go ahead and add our 4, 3, 2, and 1. Now I'm simply just going to plug in exactly what's given to us. A equals -4. Guess what? Everything in red. I'm just going to drop our -4 in, all right, because it's always going to go AB. And then our B value in blue, I'm going to put all 2's in. From here, we have to go to the calculator. I know it might be a pain in the butt. However, it's not that big of a deal, all right? So let's just work it all the way through and see what we come up with. We have our 1. We'll open a parenthesis. We'll do -4. We'll close that parenthesis. We are going to up key arrow above that division. Hit the number 5. Hit enter. What do we get? -1024. And this is how we're going to write our answer here. I'm going to put -1024 in black. We're only working with the red X. All right. So I'm going to put a red X in what it's raised to, which is the 5th power. That's it, all right? That's your first term when we're expanding here with the binomials. So our 5, we're just going to do it exactly the same. We're going to do a 5. We're going to open a parenthesis. We're going to put -4. We're going to close parenthesis. We're going to hit the up key arrow. Hit the number 4. After this, you are going to have to right key arrow over, or your calculator will want to keep you up in exponent land, all right? So again, open a parenthesis, click 2, close parenthesis, up key arrow, hit the 1, hit enter. What do we get? 2560. All right, now that's going to be x to the 4th to the red x, and then we're only going to write 1y because, well, we don't see the one above it. We just know it's a y. All right, And then we will do the exact same thing moving forward until you're all the way through. We're going to put in a 10. We're going to open a parenthesis, -4, close parenthesis, up key arrow 3, right key arrow over, open parenthesis 2, close parenthesis, x squared, or up key arrow 2, and we will get -2560. All right, and this will be written as x to the third and y to the second. Simple. Not bad. All right, let's continue to follow through. 10, open, -4, close, x squared, open, 2, close, x squared, enter, 640. And we write that as, let me go back. I don't like that. I like to keep that in color. X squared and y cubed. All right, for our next term here. Again, let's open our parenthesis. 5, open, -4, close, up key arrow, 1, right key arrow over, open, 2, close, enter, -40. Did I do that right? I don't believe I did. Let me try it one more. Oh, that's why I forgot to put the 4 above. I knew I was a little off. Yes, Mr. Richards makes mistakes too. He's not a computer. But then again, computers make mistakes, and who makes computers? Yes, humans. All right. I forgot to add that to the 4th power there. I knew I was a little off. I'm like, come on, there's got to be something wrong here. Yes, -320. We'll simply put our 1 red x and our y to the 4th, and then we'll do 1, open, 2, close, up key arrow, 5, enter. Yes, you do get 32, and it's just going to be y to the 5th. All right, let me zoom out. You might want to pause it if you're a little uncertain. I'll go all the way out. It's going to look a little tight on your screen, but hopefully you have it all. All right, number 7, moving forward, interpret the graph polynomial. All right, first thing we want to do is determine the end behavior. All right, if it ends going upwards, we're going to have a positive coefficient. Well, let's see. We read it, the graph function, from left to right. So blue's our start. Our red is our end. It's going up into the positives, meaning we need to have a positive coefficient. All right, so anything with a negative coefficient, negative coefficient, we're going to eliminate. All right, positive coefficient, negative coefficient. Get rid of it. Then we're going to determine our start. Okay, that's step 2. If it's an odd degree, it will be in opposite direction. So are these opposite directions? No, they're going the same direction. That means we will have an even degree here. All right, so we're looking for even degree. Oh my goodness, with the positive coefficient, go ahead and circle B, as we can tell that C has an oddball degree. All right, and moving forward to number 8. All right, 8's kind of a battle. It's not too difficult, but it's going to take a little bit of time. I'm going to highlight that in red. I'm going to highlight our -7 in blue, and I'm going to highlight our 2 in green. All right, and here's what we're going to do. We are going to take our zeros, and we're going to write them backwards into a binomial, a little quantity here. All right, because this is a +4, we're going to write it as x -4. This one I'm just going to easy bake oven. I'm going to set it and forget it. All right, I'm going to leave a little bit of space just to show you that. We're going to do x + 7. And then we're going to write this one in green as x -2. So do you see how we're flipping the signs? We're just putting an x in there. +4, negative, -7, +2, negative. From here, we're going to distribute. All right. I'm going to take my x times x. I'm going to get x squared. I'm going to do x times -2. We're going to get -2x. Switch colors here. 7 times x gives us plus 7x. 7 times -2 gives us, yes, wonderful, -14. From here, we have to combine like terms. Our x squared, can this be combined with anything? No. Just go ahead and write it down. All right, I'm actually going to open a parenthesis. Write that just a hair lower, okay? our minus 2x, or negative 2x, can we combine it with anything? We certainly can. They share the same variable. Negative 2 plus 7 gives us a positive 5. Don't forget your x. And our negative 14, we can't combine it with anything. Let's go ahead and bring it down. Now, our x minus 4, we are going to drop down. And we're going to do the exact same thing we just did. I know, it's kind of annoying, but it needs to be done. X times x squared, wonderful work, gives you x cubed. X times 5x, yes, gives you plus 5x squared. X times negative 14 is simply minus 14x. Then I will go to my gray again. Negative 4 times x squared is negative 4x squared. Negative 4 times 5 is negative 20x. Negative 4 times negative 14 is going to give you a positive 56. From here, we simply combine like terms again. Our x cubed can't be combined with anything. Write it in your answer. I'll box our x squareds. I see a couple of them. 5 minus 4 just leaves us 1. We don't need to write it, but we do know it's positive. Don't forget your x squared. I will underline my minus 14x and our minus 20x. So negative 14 minus 20 gives us the negative Walter Payton. Don't forget your x. And your 56, we just bring on down. Go ahead and circle your answer. Here's a little zoom out and zoom in if you'd like to pause that and take a look at it as your model. Moving forward to number 9, list the possible rational roots when given the equation 5x cubed plus 7x squared minus 9x plus 15. All right, it's going to be plus minus p over q. All right, now your p is your constant. All right, so right there, I'm going to highlight that in red. That's your P. All right, and then in blue, I'm going to highlight our Q, which is our coefficient of our first term, or the leading term there, which is 5. All right, I'm actually going to write these down real quick. So our P is 15. Oop, didn't mean for that. The factors of P are 1, 3, 5, and 15. We're going to write our Q down. 5, and the factors of 5 are simply just 1 and 5 because it's prime. Only 1 times 5 will get you to 5. All right. From here, we need to set it as P over Q. So I'm going to work my 15, and I'm just going to go ahead and I'm going to set these all over 1. All right, I'm only going to set the first one over, at least for now, because it's not going to take you that long anyways. But 15 over 1. What do we know that that's equal to? Well, yes, it's equal to 15, but let's just make sure to put that plus minus in front of it. All right, from here, I'm just going to talk you through, so hopefully you're listening. 5 over 1 equals, yes, 5. So we have plus minus 5. 3 over 1 equals, yes, 3. So plus minus 3. Goodness, that 3 just looks terrible. Look at that one. It has a huge head on it. Let's get it out of there. And 1 over 1 is simply just 1. All right, we're going to do the exact same thing, but put them over the 5 now. All right, so 15 over 5 is 3. We already have 1 there. All right. 5 over 5 is 1. We already have 1 there. But 3 over 5 we can write out. So plus minus 3 over 5. And then we can also do plus minus 1 over 5. Go ahead and circle your answer. All right. Obviously, you'll be able to find your best choice. But I always start with like the whole numbers. Take the largest. Go all the way over the ones. Work your way down, work through your answer choices, and use process of elimination. Number 10, find the remainder when 4x cubed plus 9x squared plus minus 8x plus 7 is divided by x plus 3. First thing we need to do is find out what x is equal to. All right, if we don't know by now, well, we can solve. All right, let's solve it. X plus 3. We're going to set that equal to 0. Took my time with that 3. All right, we're going to solve for x. Wow. Take your time with the 3. Take your time with the 3. Your x, bring it on down. Cancels out, equals negative 3. So we now know what x is equal to. Well, guess what we can do? All right, we can simply rewrite our polynomial here. And every time we see an x, I'm just going to put a -3 in parentheses. So 4, I'm going to open a parenthesis, -3, close it, put the 3 above. All right. I did want to keep that in black for continuity. Plus 9. Oh my goodness, yes, another x, so we'll do -3 there. Make sure to square it. Minus 8. Oh my goodness, another x, -3, and then plus 7 equals your remainder. Let's go ahead and plug it in. Hold on, trying to pull in the calculator. There we go. 4, open a parenthesis, -3, close parenthesis, up key arrow, 3, right key arrow over, plus 9, open a parenthesis, -3, close parenthesis, x squared, minus 8, open a parenthesis, -3, close parenthesis, plus 7 equals number 4. What up, easy? All right. Number 12, yes, I ran over 11, and I'll tell you what, 12 is a grind too. It's not difficult. It's just you need to work through it, all right? A polynomial with rational coefficients has the roots 3 and 4 minus 2i, all right? Now, I'm going to do a few things here. I'm going to highlight my 3. I'm going to highlight our 4 minus 2i. And I do know that when we're working with complex numbers, well, guess what? That 4 minus 2i, well, it has a conjugate. All right, and that conjugate is equal to, I'm going to highlight it later. Open your parenthesis. The 4 is going to stay the same. The only thing that changes, that minus becomes a plus. All right, so 4 plus 2i. Close it. Now I'm going to highlight that in green. All right, and there's a reason for my madness. Yes, determine the additional root. Simply 4 plus 2i. Close it. All right, we still have a lot to do. We have to find the polynomial, determine the end behavior, what degree is the polynomial, how many turning points. Oh my goodness. All right, so our x minus 3. Here's what I'm going to do. All right, remember what we did earlier? That 3, we're going to put an x in front of it. And then we're going to make that positive 3 a negative 3. All right, we're going to focus on the blue and the green to start here. All right, now that blue one here, we're going to open it. We're going to put x. That positive 4 becomes minus 4. All right. Now that minus 2i, let's set it off to the side for now. All right, I'm going to put it right about here. And I'm going to set it by itself, but it's still part of this as a whole. All right, so it's going to look a little different. Now, we're going to do the exact same thing in green. All right, we're going to open it. We're going to add that x in. That positive 4 again becomes minus 4. And then that plus 2i, well, we're just going to use it right here. All right, this should speed up the process a little bit for you. All right, instead of having to distribute so many terms and cross off so many, it works every time. All right, x times x is x squared. All right, now it only works every time when you're working with a complex number and a conjugate. All right, so if this were just all real numbers, this would not apply. All right, x times negative 4 is simply minus 4x. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. All right, negative 2i times 2i gives us negative 4i squared. But we know that I squared is equal to negative 1. So negative 4 times negative 1, well, that's simply just a positive 4, so I'll get rid of that. From here, we can combine like terms. I'm going to circle my x squared. Can we combine that with anything? No. Let's just go ahead and write it. I'm going to bring it down right about here just to set up for the rest of it, okay, guys? Then I'm going to box my negative 4x. What can I combine it with? Yes, negative 4x. Negative 4 minus 4 gives us negative 8. Don't forget your x. I'm going to underline my 16. Yes, I can combine it with 4. 16 plus 4 is 20. That's positive. Our x minus 3, we're going to bring down. I'm actually going to, give me just a moment here. I'm going to rearrange this. I prefer just to go 2 to 3 as opposed to 3 to 2 when we do our multiplying here, or distributing. All right, and then from here, let me move it just a little tighter. All right, can you distribute 3 terms to 2 terms? Sure, I just prefer to do 2 to 3. That's just me. All right, x times x squared, x cubed. X times negative 8x, negative 8x squared. X times 20 plus 20x. We'll do the same thing. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 8x is plus 24x. And negative 3 times 20 is simply negative 60. From here, we have to combine like terms again. I know it's a drag. Trust me, I feel the same way. Our x cubed, simply bring it down. We will box our negative 8x squared, and we will box our negative 3x squared. All right, like terms, negative 8 minus 3 is negative 11. Don't forget your x squared. I'm going to underline my 20x. I can combine that with, wonderful job, 24x, giving us plus 44x. And I will double underline my negative 60, giving me minus 60. I'm going to circle that, all right? Find the polynomial. Well, it's x cubed minus 11x squared plus 44x minus 60. All right. Determine the end behavior. Well, remember, a positive leading coefficient is going to go upwards. So I'm just going to point it up. All right. And to what degree is the polynomial? And just like number 1, well, what is the greatest exponent? It's 3 in this case. And to determine how many points, if there are any, we would do 3 minus 1, which equals 2. And you have now filled out everything for this. And as you can see, if you take this route, it cuts down on a lot of multiplying and canceling out. All right. I find it beneficial. You may not. You might want to take whatever route you're taught. But it's kind of just the way that works best for me. Moving forward to number 13, and then we'll get to 11, the beast. Determine the perimeter and area of the shaded triangle. All right. So perimeter here. Let's just determine a couple things here. It's 35 I'm going to highlight. Directly across is a 35. All right. We've got either the width or the length, however you want to do it. Now, we need to find this portion here. But in order to do so, we need to take all of our 42. All right. And then we need to do something with this 6x. Well, we're definitely not going to add it on. So we will subtract it, 42 minus 6x, making our other side 42 minus 6x. Now we have our 4 components here, because when we do perimeter, we highlight this in orange here. All right. Your perimeter is just to add all of the sides together. So our P equals 35. We're going to do plus 42 minus 6x. All right. Plus another 35. and then plus another 42 minus 6x. I know, seems like a lot of work, but this one you guys can definitely nail like no problem. All right, 35, circle, 42, circle, 35, circle, 42, circle. And what do you guys get when you add all of those together? Wonderful job, 154. I'm going to go ahead and write that right here. All right. And then we will get, hold on, negative 6x minus 6x. I'm going to box. That will give us negative 12x. All right. So that right there is your perimeter. Now, for the area, I think they gave us another hint here. An area is just simply length times width. All right. So we're just going to solve for our area. We're just going to take 35, and it's solo. It's going to drop it right there. We're going to multiply it to 42 minus 6x. All right. So 35 times 42, let me call on our calculator here. That's going to give us 1470. All right, if you're working with inches, if you're working with feet, if you're working with centimeters, millimeters, for us, we're going to go feet. Squared. All right, 35 times negative 6 should be negative 210 if I'm correct. 35 times 2 is 70. Yep, times another 3, negative 210. Don't forget your x. And go ahead and circle your answer for your area. All right, number 11, I just give it its own page for. All right, I know. I mean, it's a grind. It's not fun. It can be fun if you're into this. I mean, I kind of like it. But given the solution, x equals 4 to the equation x cubed minus 6x squared plus 10x minus 8 equals 0, determine the conjugate, complex and conjugate roots. Sorry, I forgot to add in complex there. All right, so I'm going to highlight my x equals 4. That is going to be our divisor. Nothing changes because we know that x is already equal to it. All right, that's going to be step 1 out of the way. Done. Moving into step 2, let's put in our coefficients and constant setup. All right, so our coefficient, let me actually just highlight this a little bit. All right, what's in front of that x cubed? Yes, it is a 1. We're just going to write it. All right. Negative 6x is our next coefficient. Positive 10 is the one that follows. I'm actually going to get rid of the positive. I'm just going to put the 10. And then our negative 8 is simply last but not least. Perfect. From here, we are done with step 2. Step 3 is simple. Drop first the coefficient. Drop first coefficient. I'm just going to go ahead and drop it. All right, that's our 1. And then step 4, distribute divisor. Continue, combine like terms, and continue. All right, well, 4 times 1. Man, that arrow just looks pitiful. All right, that's going to equal 4. Negative 6 plus 4 gives you negative 2. 4 times negative 2, well, that equals negative 8. 10 minus 8 is 2. 4 times 2, that's 8. Negative 8 plus 8 leaves us nothing. Nobody home. Cancel them out. All right, we've finished step 4. Now it says step 1, rewrite as quadratic. All right, what we have here, subtracting an x from the first 3 terms and label a, b, and c. All right, well, quadratics are always going to be an x squared, so our 1's going to come down, except we don't need to bring it because how many x do we see? Yes, just 1. Make sure to square it. And as you can tell, if you do subtract 1 from your cubed, you get a square. All right, then we're simply going to, I'm actually going to arrow that down. Our negative 2 do the same thing with. All right, and as you can tell, our x squared just simply becomes x And then I'll simply bring this bad boy down, our positive 2. We'll write it as plus 2. And we don't bring anything with it because that x minus an x leaves us simply x squared minus 2x plus 2, giving us our quadratic. Ooh, I forgot to add that when I crossed it off, but it equals 0. So we're good. We're set up. We're ready to rock this thing. All right, now we need to label our a, b, and c. Our a is the coefficient of x squared, so that equals 1. Our b is the coefficient of x, so that equals negative 2. And our c value is 2, so we've done number 1. All right, step 2, plug into quadratic formula. Well, here is the quadratic formula here. Our negative b, all right, we're going to do negative. We're going, actually, let me put x equals negative. Our b value is negative 2. Close it. Plus minus, open up there, we're going to do b squared, so negative 2, square it. We're just following the formula here, minus 4 times your a value, which is 1, and our c value, which is 2. All right, we're going to set that over 2 times a, which is simply 1 in this case. All right, I'm just going to work through it real quick. Maybe not real quick, but actually I want to do something just to show you what I'm highlighting. That's all. All right. We're going, let me make that a bigger highlighter if we're going to be working here. All right, perfect. Your x equals, I'm just going to bring it down. All right, remember, we're looking for x here. Then I'm going to do the arithmetic. Negative times negative 2 gives us a positive 2. All right, your plus minus, just bring it down. So it's just like Math 2 last year. All right, this portion. And I know this portion, this was tough, but we did get through it, but it was definitely more of the challenging content that we went through. All right, as you can see, I did not highlight the radical here. So what we're going to do is we're going to simply open a parenthesis, put a negative 2, close it, hit x squared, minus 4, open a parenthesis 1, close it, open a parenthesis 2, close it. What do we get? Negative 4. Now, since our radical here wasn't included, I'm actually going to bring it down. And what I did in blue was negative 4. And then we're going to set this over 2 times a. Well, 2 times 1 is 2. Are we finished? No, unfortunately we're not. We have that negative radical there, but we did step 2, and to be honest with you, I didn't even realize I skipped over it. Sequence quadratic formula. I was just used to going for it. All right, now I'm going to rewrite, because number 4 says take square root of negative, or rewrite with factors of negative with the greatest perfect square if needed. All right, so let me open this up here. I'm going to actually just highlight this. I'm going to bring down our x equals. I'm going to bring down our 2. I'm going to bring down our plus minus. All right, now what do we know about those negative numbers? Yes, we would use we'd use 4 times negative 1. And that's imaginary. So what we can do is the square root of 4 is simply just, yes, exactly, it's 2. But don't forget to bring down the I with it, representing that negative 1. All right, and again, now we will set this over 2. Are we finished? Unfortunately, we're not. All right, if possible, we have to divide the numerator terms by denominator, if possible, in right answer. Well, we know 2 and 2 are both divisible by 2. All right, so we're just going to simply write x equals. And 2 divided by 2 here is simply 1. I'll write that in red. All right, I'll bring down our plus minus. 2 divided by 2 again, yes, it's just 1. I'll write that in red. And don't forget to bring down your I with it. And that completes your review. A few of these are lengthy. However, if you're looking to work through in a timely manner, knock out what you can, just like you would the ACT or SAT. then go back to the more challenging ones and do the best you can and go on to crush this unit to a assessment. Let's go.